just gave you is some additional practice that we can now do now that we've learned our unit circle and using the big ideas of our unit. What makes trigonometry a little bit difficult as a unit for grade 12 is now that you've learned radians, every single trig question that you've had in the past 3 years in grade 10, 11, and 12 is now a new question if we just change it to radians. So we have to be able to do all the questions from the previous years and just opens up a lot of possibilities. So we need practice. So what we're going to look at is how can we use the information that we've done and answer a few more questions. So here's example 1. Again, a number 1 strategy you're going to use when solving trig questions is drawing a triangle. So this question starts off with if cos theta is 3/8 and theta is not in quadrant 1, find sine of theta and tan of theta. So we're going to want to draw a triangle, but when we draw this triangle, we want to draw it in the right quadrant. And theta's not in quadrant 1. But because cos is positive, you would look at your cast rule and say, if cos is positive, I know it's not here and not here. It's either in quadrant 1 or quadrant 4. But I was told it's not in quadrant 1. It has to be in quadrant 4. So I go to quadrant 4, I draw an angle, the terminal arm of an angle. I go back to my nearest x-axis so that I can label my reference angle. And once I've drawn that triangle, I would also know, well, if cos is 3/8 and cos is adjacent over hypotenuse, I can label the adjacent side as 3, the hypotenuse is 8, and now you can do a squared plus b squared equals c squared to get the other side. And as I mentioned, you're going to get pretty quick at this, so I want you to do some mental math. Try to figure out what the other side is going to be on your own. Did you get the square root of 55? Because c squared, your hypotenuse would be 64. This side, 3 squared would be 9. 64 minus 9 would be 55. And the other side will be the square root of 55. Right? Because you're doing a squared plus b squared equals c squared in your head. You would know that this one is 9. You would know this one is 64. This is the one that you're trying to figure out. So 64 minus 9 would be 55. That would equal b squared, and then you'd square root both sides. So b would be the square root of 55. And from this triangle, you can now say what sine of theta is. Because you know sine of theta is opposite over hypotenuse. It would be root 55 over 8, and it would be negative because we're in quadrant 4. And tan of theta, opposite over adjacent, and negative because we're in quadrant 4. Now, a gut feeling that students have with question number 2 here is no. You just did your unit circle, and you look at all the points on your unit circle, and this isn't one of them. However, we only found some points on the unit circle. There's actually an infinite amount of points on the circle that we didn't fill in. So now all of a sudden it's like, oh, shoot, maybe this one could be. How would you know? Well, here we can use our big idea as well, or our equation of the unit of the circle. So the unit circle's equation is x squared plus y squared equals 1. This is the same as the big idea that sine squared theta plus cos squared theta is always equal to 1. So if this point is on the unit circle, if we square the x coordinate and square the y coordinate and find out what it's equal to, if it equals 1, we can say it's on the unit circle. If it doesn't equal 1, then we can say it's not on the unit circle. So I'm going to check. If I take my x coordinate, root 3 over 3, and I square it, and then I add my y coordinate and square it, what does it equal? Well, root 3 times root 3 would be 3. 3 times 3 would be 9. Root 6 times root 6 would be 6. 3 times 3 would be 9. So because we simplified that and it equaled 1, we say, yes, that point is somewhere on the circle. If it was equal to 1.2, you would say no, it's not on the unit circle. So if negative 12 over 13, comma y is a point on the unit circle, in quadrant 3, find y. So a couple of ways that we could go about doing this one. The way that I like the most is to draw a triangle. You know that it's in quadrant 3. Draw it back to your nearest x-axis. That allows you to label your reference angle. And using your big idea, you know that the x-coordinate is cos of theta, and the y-coordinate is sine of theta on your unit circle. So what I would do in this one is I would say, I know that cos of theta is equal to negative 12 over 13. If I was labeling things on a triangle, then I would know that my adjacent side is 12, my hypotenuse is 13. And now I can do a squared plus b squared equals c squared. 169 minus 144 is the square root of 25, which will just be 5. Obviously, my triangle is not drawn to scale. And once I've drawn my triangle, I can now say what sine of theta is. I look at my reference angle, opposite over hypotenuse, and because it is in quadrant 3, sine of theta would equal negative 5 over 13. The question asked me to solve for y. I know that y is equal to sine of theta, and so this will be negative 5 over 13. In reality, can you see that the point they're actually talking about is on a tiny little circle right here? And that's the point they're talking about. We drew a much bigger triangle. We didn't draw the triangle on the unit circle, we drew a bigger one. Because this length is 12, unit circle has a radius of 1. Well, we took that triangle and figured out what sine of theta would be. Your y-coordinate on your unit circle is always sine of theta. That's where we'll end for today.